So good afternoon, everyone. Last class, we were struggling to, return a value from a thread handler. Okay, so that was the difficulty which I was facing. Uh, we shall quickly revisit that. See, what I was doing is in the down counter, I was trying to find the sum of the numbers which are printed. Okay, so I was sending some 8 or something here. So N2 was 8. So 8 was coming here, and we were running a loop starting from 8 to 1, and we are summing up. So I was declaring a local variable int sum. This was a wrong thing I was doing. That is because, see, within a function, any variable that you declare, it will be stored on the stack. All of you agree? The local variables are stored on the stack. But this is a thread handler. Moment the thread
Yes, sir.
returns, the value would be destroyed, and there is no meaning to the address of the value that you are returning. Okay, so what I should have done is I should have allocated space for the variable on the heap using malloc function here. Okay, so I'm doing int star sum equal to malloc, and I'm allocating one integer size memory, and then sum is 0, and the summing up is done, and you just return the sum. So in the thread, while joining, the main thread will wait for the thread to resume, thread to complete. And once it comes back, the return value which you are saying return here would come into this second variable and result to which I am displaying it here. Okay. So if I run the program, up down one dot c minus o up down. So this is not synchronized, so let it go on. So the down counter will go from 8 to 1. So sum of 8 numbers is 36. So the received sum is 36 here. Okay. So you can return a value from a thread, and that can be captured within the body of the main thread which has created it. So here, and the point where you have to catch the return values at the point of thread join here. Okay, so this part you need to understand that any value that you want to return, it should be a dynamically allocated variable. Since it is a pointer here, int star sum, I just have to say return sum. I should not say return and sum. Okay, so this I have to remove. And this was a mistake which I was doing. I was declaring local variable and trying to return its address. So that is why it was not working the other day. Okay, so this part is clear. Now, one more thing is, it is not that you can only return the uh, a variable which is dynamically allocated. You can return a function pointer also. You all know function pointers, right? A function can have a pointer, and the return address being void star, it can be a function pointer also. So how a thread can return a function pointer is another demonstration. I was discussing with Vinod the other day in the afternoon. Saturday, I had a session with him. He told me that in many of his development projects, he has to return pointers back to the uh, main from the threads. So he specifically told, can you show me a program how to do that? So I have a sample program here, return one pointer. Just observe carefully that I have a very simple function, void hello, and it is just saying hello from returned function, or you can type anything here. So this is the function that will be executed in the main. Okay, and the address of this will be returned by the thread. So as usual, we have a thread handler here. As you can see, void star thread function, void star argument, the usual signature of a thread handler. And within this, just see what I am doing here. I am just saying void star hello. Okay, so the function address I am passing back to the main. So you can return pointer of a function. As you know, name of the function itself is an address, right? Isn't it? name of a function itself an address, and since the type of the return is of star, it should be of pointer type, generic pointer, so the type casting has to be done void star hello. Now in the main, when I create a thread, so I create a thread and thread function you mentioned here, and in the join, just see what I'm doing. In the return, I am saying ampersand return. So what is the type of this ampersand return? It's again void star return. Okay. Now this is a generic pointer again, but function pointer, it should be typecast into appropriate function pointer type. Now how do I declare a function pointer to this hello function? The return type of this is void and it is not accepting any argument. So if you recall from our C programming, we have to declare a function pointer like this. The return type is void and it should use in bracket star some pointer or anything here. This is a name of the pointer. And since you are not passing any argument in the function, it should be blank here, is equal to the typecasted version of star and this. And return type has to be typecast into this type. That is the function pointer not accepting anything and it is not returning anything. Okay, so this return address which has come from the thread has to be typecast. And now if I use the function pointer here, this is actually executes the function hello. Okay, so this is a very simplistic use case scenario where a thread can return address of a function and the function can be executed from the main. Now if I compile this, okay, this is C minus O. Sorry, minus O should be here. What happened? Turn one PTR. Oh my god, it's right those. Oh my god, it destroyed that file. Minute. Okay, so I think so. I have the executable. Yeah, I have the executable. If I run the executable, as you can see, hello from returned function. So I am able to run the program and the thread will return the address of the function and the function executes in main. Okay, so this is another use of the return value from the thread. Is this point clear? Okay, so you need to practice these programs. I'll share the code with you and just you can go through that. Okay, yeah. Now, I was telling you about the second
Yes, sir.
argument of the pthread create. I think so. Arpita was asking me
Okay.
how to use that second argument. So if you see here, pthread create, first argument is the thread ID. Second argument, we were putting null all the time. But here you can specify address of a variable which is of type pthread attr underscore t. It is actually a structure which contains many subparts. Okay, now what is this for? This is for specifying many things. First thing is you can uh, make the thread detached. Now, whenever you create a thread and main has to wait and deallocate all the resources held by the thread. Okay, but what if I want to give this freedom to the thread itself? The thread, when it executes and completes, all the resources held up by the thread should be deallocated automatically. If you want to do that, then what you have to do is you have to first initialize this attr variable which are declared here using the pthread attribute in it. Okay, and then set the detached state. So there is a system call called pthread attribute set detached state. You have to pass first argument as address of this variable attr, and then mention this defined constant pthread create detached. Once you execute this and when you create the thread, the main cannot wait for the thread to complete. If you try to use pthread join, it throws error because the thread is detached completely. So it will automatically deallocate all the resources automatically. Okay, so this is one added advantage of making the thread detached. Okay. The second thing is, as I told you, thread will have its own address space like stack and all. So how much stack space you want to allocate, that can be done with the second system called set stack size. Again, first argument has to be the address of the address attribute. And here you mention how much memory you want. So he is using 1 MB space for the stack. Okay, so you can use 512 into 512 or whatever. So depending on how much memory you want to allocate, depending on the application requirement. So this will see that appropriate stack size will be allocated. And the third thing is what type of scheduling policy you want to adopt. Suppose you have 5 threads. Okay, so the thread should be executed in a certain manner, right? So you can use round robin scheduler or first in, first out scheduler, anyone. In round robin, every thread will have a fixed amount of time. After the time elapses, it will switch to the next thread. But if I say first in, first out, whichever thread which has come first will be executed first. Okay. And after completing that thread, then it will go to the next one in the queue and likewise. So you have the freedom to decide what scheduling policy you want to adopt. Again, here pthread attribute set scheduling policy. First argument is the address of the attribute variable, and then second is the policy name. Now, another thing is the after the scheduling algorithm is set, you want to set priorities for the threads. Like in certain applications, certain threads you want to run before the others. Okay. For example, in uh, let us say at the airport while checking in, okay, you have to so, uh, check in first and then go to the boarding, get the boarding pass and then go to the um, the terminal where you'll be taken to the aeroplane. Now that sequence has to be followed. So assuming that each one is executed as a thread, then the thread priority should be first check-in, then the boarding pass, then the boarding of the bus, and then alight, going into the aeroplane. So those four sequences you want to execute as priority based scheduler. So here higher value means higher priority. You can go up to 1 to 99. Okay, so that's a kind of priority is allowed in threads, assuming that at most 100 threads will be there. But that's a very rare case. And here, for specifying the priority, you need to define one more structure variable called schedule param. Okay, so this schedule param has a property called as schedule priority, and that should be set to a number between 1 to 99. So here I'm setting thread priority as 3. Now, this is meaningless if you have only one thread. You should have at least 4 or 5 threads, and you should set priorities for each of the threads that you want to execute. So pthread attribute set priority and all this. And here pthread create, you have to pass as second argument this ampersand attribute. So whatever parameters you have set through all these previous steps 1 to 5, they will be effective for the threads that you create from here on. If you want to specify different priorities for different threads, then you should have different variables attr1, attr2 like that for each of the thread, and then you pass them to the pthread create functions that we execute here. Okay, so here I am specifying for only one thread all the attributes and trying to execute. Okay, so this just runs like any other thread, nothing much to view here. But if you compile this -o, so main thread continues and thread is running, main thread exiting. So here deallocation is done by the thread itself. As you might have observed that I am not executing pthread join anywhere. Okay, since you have detached the thread, I am not using pthread join down here. Okay, our last step used to be pthread join like this, isn't it? This TID, and then we are putting null here, new return value. So this used to be our regular sequence of execution, but you should not do this at this stage because you have chosen the detached mode of thread execution. So if you try to do this, it will throw an error. Is that clear? Okay, so these are some very small or finer points that you should be aware of whenever you are creating threads and you want to have greater flexibility with respect to what scheduling algorithm to choose, what priority to set, whether you want attach mode or detach mode. So all that can be done. Okay, so this program also I will share with you and you can just go through. Hmm? Any doubts here? Okay. Okay, so it all sounds easy, but when you need to do a little bit of practice so that you get real hands-on, and it is firmly with you that if whenever you encounter or uh, a program containing threads and the priority setting and all, you should be able to figure out what all the program is doing. Okay, yeah, okay. Now, next thing is whether it is threads or processes, sometimes we want certain processes to run indefinitely. That is, at the beginning, when you start a system, the process should be running and it should remain running till the till the operating system shuts down. We should not be able to, stop that process or kill that process. Okay. Now I have a small program here. Uh, Let us say I have a program like this. I'm just creating one process here. You know how to create a process by now. You have to take a PID variable and say PID equal to fork. So this will return twice. With PID 0, it will return the child process space. What I'm doing here is I'm just putting it in a infinite loop. Okay. In the while loop, I'm sleeping for 1 millisecond, 1 second. And then in the parent, I'm just returning. It means that child will continue indefinitely and the parent will exit. Okay. Now, what is the implication of running this program? We shall see. K dot C minus O K dot slash K. Now, you will not get any output, but if I execute the PS command, you will see that the process K is running. This is the PID of the child process. Do you see this? It is indefinitely running. Okay. Along with bash, the shell, and the ps command you just executed, the k, which is your process, which is actually a child process which is running here. Okay, yeah. Now, can I stop or kill this process? It is possible to kill this process. If I say kill 1221, you will not get any output. But if I now execute ps, you will see that the k is gone. It means I could kill the process. Okay, so such processes are all foreground processes and they have a terminal from the terminal, you can stop those processes or kill those processes completely. Okay, but there are certain programs which are called as daemons. These daemons are nothing but processes which will start when the system boots up and remain in execution till the system is shut down, and you cannot kill them. Okay, that is required because let us say you are running a web server. So when you start web server, if a normal user kills it, you are one, right? Right. Even super user kills the process by checking its PID and then say kill PID. The web server stops working. Okay, it should not happen. So nobody should be able to kill certain very vital processes. If I want to convert a process into daemon, what is the procedure I need to follow? Okay, so there is a well-defined standard that you need to follow to convert a normal process into a daemon. Okay, so daemon is nothing but a simple user process that lives long and has no controlling terminal. Okay, now what is now how do I create a daemon? For that, you need to be aware of certain concepts. Now, if whenever you log in, you have a session. Okay, so within the session, you will have many processes, and certain processes can be in a process group. As depicted here, this outer boundary is a session. Within this session, there can be many processes, and few processes can be inside a group. So, for example, process 1 and 2 are in process group 1. Okay. Similarly, P3, P4, P5 are in process group 2. And this P6 is in process group 3. In a group, there can be only one process also, one or more processes. Okay. And all these processes group together is a session. Okay. Now, why I need to learn about session and process group and all? We shall see uh, in the creation of a daemon. All these concepts are required. Now, how do I create a daemon process? So, what I do is I create a process. This is your main process, and when you create a process, okay, automatically it creates a session and also a process group. So this will be inside a process group, and it will be inside a session. So a new session will be initiated whenever you create a session. Whenever you run a program, a new session will be created. Within that, there will be a process group, and within that, there will be only one process. So this is a scenario, and this process group ID, this will also have an ID, PGID, and this process will also have a PID. Now, if the PID is equal to PGID, then we say the process which is here is the process group leader. Okay, it's a process group leader. Now, uh, okay, I made one small mistake. This when you create a process, so it will be in the process group. This session will not be there. Okay, so let's forget about this session. Session will be created. You have to create this session. So whenever you create a process, it will be inside a process group only. There will be no session. Okay. So this is the process group leader. And if it wants to create a session now, the first requirement is it should not be process group leader. It means the PID of the process should not be equal to PGID. How do I do this? Okay. Now, whenever I create a process, its PID will be equal to PGID. Now it appears impossible to create a session because all the while this is true. Now the trick is, let this create a child process. Okay. So what I do is I will create child process here. How to do that? We know use a fork. Okay. So its PID will be different. Let's say the PID of this is 100. Parent is 100. This is 101. And process group ID, we know it is 100 because first time when you create a process, the process group ID will be equal to the PID. These two will be equal. But if you see, the child process will have a PID other than 100 and it will not be equal to PGID, isn't it? So this will not be process group leader. Now what I can do is, after the parent creates the child, I can terminate this by executing exit. Now what happens is, in the group, the parent will vanish and only the child will remain here, which is not a, the process group will remain, and within that only the child will remain. Now you see that PID is not equal to PGID. That is exactly the requirement needed to create a session. Now this child can call set SID to create a session around it. So what happens is, now a new session will be created like this. Okay. So now these are the basic requirements of a daemon to be created, and that is why you need to follow all these processes. Okay. Once the session is created, another problem now what happens is, when you create a session, the session ID will be equal to the PID. This is another problem that we'll have. Now if we see, the session will also have a SID which will be 101 now. Now again the problem comes, for a daemon to have, not to have a controlling terminal, the PID should not be equal to session ID. Again what I can do is, this child can again fork, create a new process 102, and this can exit. Now you see that this is 102 and this is 101. The process ID is not equal to session ID, and hence this will be detached from the terminal. So no terminal, or terminal means your keyboard, can send a kill command to kill this process. Okay, so that is how a process can gradually promote itself to a daemon process. So daemon basically has to run in the background, and no terminal command should be able to terminate it or stop it. Okay, so these are few of the processes that we need to follow. Now, if you have not followed much of this, don't worry. We shall see through a program how to do all this. Okay, so step by step, we shall see what is the process needed to create a daemon. Now, why I'm explaining daemons? Because invariably, when you work in the development field, you will always encounter daemons. Okay, so we need to know what daemons are, how to create them, and what is the sequence that is followed in the process of creating a daemon. So let us step by step create this. This is, because it's already done. I want to take you through step by step how to do this. So nano d.c. So these are some of the header files that are required: standard library, unistd, stat, fcntl, syslog. We shall see why all these are required. Now, as I told you, I want to, now you know that this is the main, when you run, it is a process, right? It's a parent process. Now I want to create a child process. So PID underscore t PID. Then PID equal to 4. So now child is created and the process group is also created. Now I want the parent to exit. So PID greater than 0. We know this is parent process space exit. So that only the child remains in the group, and the child PID will not be equal to process group ID, and hence it can call the set SID API. This will actually create a session. Now, for every API, normally it is customary to check whether it goes through successfully by checking whether it returns a negative value. So here you can say printf error creating session, and then you just say return 1. So something went wrong. But if you come out of this, the new session will be created. But now problem is session ID will be equal to the child PID. Right. So again, you have to do one more fork here. You can use the same PID in one more fork. And as before, again, if PID greater than 0, you have to exit. Now what has happened is the grandchild is the only process in the process group, and it will be detached from the terminal. That is the requirement. Now what might happen is this program might be running in some folder. As you can see here, this is running in /home/sfr lecture 5. Now whenever a daemon is completely created and run, no other program can use this folder. Now this becomes a problem. Now I want to free up this folder from the daemon. For this, you have to carry out the following step. After you have created a session, here the next thing is to say change directory to root. It means the daemon will run on the root directory so that no subfolder is occupied. Okay, so that other processes can use it. And next thing is, if the parent has used some file creation masks, the daemon will also inherit them. So you want daemon to free to set any uh, access rights on the files which it opens. So there is a command called as umask 0. So what it does is it will free up the daemon from the parent, and any file permissions which are set by the parent will not be affected in the daemon. So daemon, whenever it opens a file, it will have access to all the things. And next thing is the daemon should not be able to print any messages on the terminal. Imagine if there are 10 daemons running, each daemon starts printing something on the screen. The screen will be full of some messages which you cannot make out. So daemon should not print anything on the terminal. For that, you have to close the terminals. The standard input, the file descriptor of that will be 0. You have to close it. Similarly, you should be able to close the standard output also. And there is one more standard error that also should be closed. Now this file std out file number, these are nothing but the file descriptors. The standard file descriptors are 0, 1 and 2. Okay, this is what you have to do. And what will happen when the daemons try to write something to the terminal or read from the terminal, right? So uh, if you do not tell what exactly should happen, then the daemon will start generating errors. So to avoid that, you have to do the following step. You have to open a device called as null, and for the input device, you should say o read only. Similarly, you have to do open a device null or override. This is for the output terminal. So any daemon, when you try it will try to write to this device null, and it will not generate any error. And whenever it tries to read, it will encounter end of file, and that is not a problem. And if you try to write anything, it will be ignored. So these are some of the steps the daemon should execute. Device null, then read, write. The errors file will be can be read or it can be written to. Okay, so these are the steps the daemon has to do. Now, since I'm closing the display terminal for the daemon, if the daemon has to put some messages, like the daemon, when let's say web server is running, and a user has sent a request for a HTML file, and if the file is not present, it has to report that the request is invalid, and it should record that. Now for that, you have what is called as a system log. So first thing is you have to open that log file, and you can mention what is the name of the daemon. So let us say I want to call this as my daemon, and in the file, what all you want to log? I want to log the PID. Now this daemon has a PID that will be logged, and also indicate that it is coming from the daemon. Daemon. And now if this is the daemon currently, now suppose if I want to send a message to the system log or the log file, I just have to say syslog, and this log has different levels: log info, log error, log critical. This is not a critical error, just the information I want to write, that I want to indicate that daemon has started. Okay, and if this want this daemon to continuously write something to the log, you can put this in a while loop, and you just say syslog. Instead of printf, I'm doing syslog. That is what you need, and you just say info. You can say daemon running. Just observe above message is started and this is running. So continuously you will see daemon running with its PID, and you can sleep this for, let us say, 5 milliseconds or 5 seconds, whatever, and then return 0. Okay. So this is the complete process of creating a daemon process. Okay. So let's see if it goes through correctly. Gcc d.c minus o d. Okay. There are some errors. I think so. It should be o underscore read, right? Okay. So let me open up my original file here. I think so I have not included some file. Yeah. I forgot to include this stat.h and fcntl.h. That is why it is giving error. So let me compile this program, which is very much the same, minus od. Okay, now this daemon is also an executable file. Now daemons are run in the background, so you should use ampersand here. Okay, so that it will execute. As you can see, it has put up its PID. So daemon is running with its PID 1294 in the background. Okay, now how do I know it is running? So the command is ps minus xj. You will see that daemon D is running here, and if you see, it has a PPID of 300 and there's a PID of 1296. Okay, and the terminal type is question mark. It means it will not have a terminal, controlling terminal. It means if I say kill, I know it's PID, right? 1296. Let us see what happens. See, it just came out, not giving any message, but you still that the daemon is running. It means you cannot kill the process using kill command because it is detached from the terminal. Okay. Now, how do I know this daemon is running and it is writing messages to the log? Okay. So for that, you have a command to execute and see. Of course, there are two commands. One is very useful command, journal control, journal control minus F. It means any message which is repeatedly coming, it will be displayed, and I want to get only messages belonging to my daemon. So now we will see. Have I made any mistake with respect to the spelling? Just 1 minute. I'll just check what name I gave to my daemon. This is the my daemon, DAEMON. Yes minus XJ. Yeah, that I terminated the daemon. Yeah, the daemon is running now. Now, to execute this command, there's one more command. Let's see whether this works for me. Tail minus f slash var log syslog. Okay, so as you can see, the daemon, my daemon is running here. Daemon is running. But problem with this is this will display the messages only once or twice. It is displaying here daemon started and daemon running. Okay, it's updating. That's fine. Okay, I put a delay there. So this is also displaying, but you will see many other messages also coming here. Okay, so it says what is the name of the daemon and its PID. It's continuously running. Okay, it's still running there. As you can see, the PID is 1311. Okay. Now this command should have run journal control minus F pipe grep my data. Yeah. As you can see, it is more neat and clean. So continuously it is showing. Okay, so it will only show the running status. A daemon is running after every 3-second delay. Okay, so it is possible to convert a normal process into a daemon process which will keep running till the system is closed. That is, when I close this terminal here, that daemon will vanish. So next time when you start, again you have to execute the daemon. Of course, these are all system daemons. They will be started by many other internal processes, and they will remain in action till you shut down the complete system. So the reason why I covered daemons is a very, very important topic you should be aware of. And this diagram should help you to understand the relationship between the various processes in the session and the process groups. And what is the sequence that you need to follow to get a normal process becoming a daemon process. Okay. And daemon process will not have a controlling terminal. If you observe TTY, you have question marks here. The shell has a terminal. That is, the shell can be altered through the terminal. And there is a other uh, scheduler process, as you can see as DPAM, that also is running and it will not have a controlling terminal. Similarly, there is one system process which is running as a question mark. So wherever you see a question mark, these are all daemon processes. That is how you identify a daemon from a normal process. Okay. Is this concept of daemon is clear? Yeah, yeah. Yeah, yeah, true. Because see, web server has to be running all the time and nobody should be able to stop it. Okay, that is one case. Suppose you want to download some file, there should be a file FTP server running.
So this daemon process will be
Then
used
you want to
when
send us you
we
mails.
have a
This
long process
mail
which has to be run, and
mailer daemon should be running.
that's the only use case
So
in a real
daemon
environment.
processes are all
Daemon
system
process.
processes which nobody should be able to stop.
Hmm.
Okay, and only the administrator will have the privilege to create the daemon. Now I have logged in as a user SFR, which has a root privileges, and that is why I'm able to create daemon here. If I create normal user and run the same program, it will not run because you don't have the privileges. Yeah, yeah. See the if you make a daemon, it will be running all the time. But now if I close and come back again, that daemon will not be there. You have to again run it. Okay, and there is one
Okay. But till how long it will be running? So I
there
mean,
is one
it's only
configuration
hard about
file
what
in which
admin
if
can
you
do, or
specify this daemon
it
has
will
to
be
run at
continuous
the
running
time
until
of
the client is
starting.
on.
Okay, so automatically it will run at the boot time and remain running till the end. Okay.
Mm.
So normally, system administrators they know exactly where to put
Okay.
these daemons, and there will be a large list of daemons running. Okay, and if anything happens to the daemon, they know how to fix those things. Okay, if you only way to
Mm.
remove them from execution is remove from that configuration file. Of course, there'll be a GUI
Okay.
using which if I remove from the list, automatically next time when you run, the daemon will not be there. Okay. So you can take it down for maintenance, and once it is bugs are fixed, you can again make it run. Hmm?
Okay.
Okay. So I will share the code with you. Just see if you can execute that and see yourself how a daemon can be created and run like this. Hmm? Okay. Hmm. So we close for today.
Okay, sir.
Yeah, yeah. I'll do that. Okay. Bye then.
Okay. Yeah, sure, sir. Yes, sir. Share this diagram as well, sir. Yes, sir. Thank you.